Assalamualaikum warahmatullahi wabarakatuh. Hai semuanya, balik lagi dengan aku, Rini Anggraini. Di video kali ini, kita akan membahas sebuah konsep yang sangat penting dalam dunia geoteknik, yaitu Rock Quality Design atau disebut juga dengan RQD. Nah, pada video kali ini, kita akan mempelajari bagaimana konsep ini berperan dalam evaluasi kualitas suatu batuan. Selain itu, kita juga akan memperdalam pengetahuan mengenai aplikasi praktis dan mengeksplorasi dampaknya yang mendalam dalam proyek-proyek rekayasa geoteknik dan konstruksi. RQD ialah metode atau parameter yang digunakan untuk mengukur sejauh mana suatu formasi batuan ini utuh atau retak, dan juga memberikan gambaran tentang seberapa baik batuan dapat mempertahankan integritasnya. RQD juga diukur dalam persentase dan biasanya digunakan dalam industri konstruksi, pengeboran sumur, dan rekayasa geoteknik. RQD tidak hanya sekedar angka, tetapi mencerminkan kompleksitas dan karakteristik batuan. Dinyatakan sebagai persentase, RQD dihitung dengan merinci panjang inti batuan utuh dalam setiap interval pengeboran. Dalam esensi, RQD memberikan pandangan holistik terhadap integritas batuan. Yang pertama, stabilitas lereng. RQD berperan sebagai pilar penilaian dalam analisis stabilitas lereng dengan memahami sejauh mana batuan dapat mempertahankan keutuhannya. Insinyur dapat merancang solusi yang sesuai, mencegah potensi kegagalan lereng, dan memastikan keselamatan struktural. Yang kedua, untuk perencanaan terowongan. Dalam proyek terowongan, RQD membantu insinyur merencanakan rute yang optimal, evaluasi kualitas batuan, membimbing pemilihan metode konstruksi, dan memitigasi resiko geoteknik. Yang ketiga, pengeboran sumur. RQD menjadi alat kritis dalam pengeboran sumur untuk memahami karakteristik batuan di sekitar sumur, memengaruhi keberhasilan pengeboran, dan pemahaman potensi sumber air tanah. Ada desain fondasi. Dalam desain fondasi, RQD memberikan wawasan kritis tentang kemampuan batuan mendukung struktur. Keputusan ini terkait dengan jenis fondasi dan perencanaan struktural dapat dioptimalkan dengan memahami nilai RQD. Proses pengukuran RQD melibatkan analisis panjang inti batuan utuh dalam interval pengeboran. Ini memerlukan keterampilan dan pemahaman yang mendalam tentang geologi dan struktur batuan untuk menghasilkan data yang akurat dan untuk evaluasi kualitas suatu batuan. Nah, di dalam perhitungannya, RQD memiliki rumus, di mana rumusnya itu RQD sama dengan contoh terukur dibagi total panjang dikali dengan 100%. Lalu akan didapatkan nilai suatu RQD tersebut yang dimana hasilnya akan dimasukkan ke dalam tabel klasifikasi untuk melihat kualitas massa batuannya. Nah, di mana dalam tabel ini terdapat jika nilai RQD kurang dari 25%, kualitas massa batuannya sangat jelek. 25 hingga 50% kualitas massa batuannya jelek, 50-75% kualitas massa batuannya sedang, 75-90% kualitas massa batuannya baik, dan 90 hingga 100% kualitas massa batuannya sangat baik. Nah, teman-teman, memahami RQD ini bukan hanya menjadi tugas seorang geoteknik, tetapi keharusan dalam evaluasi risiko, di mana mengidentifikasi potensi masalah geoteknik dan mengambil langkah-langkah mitigasi yang sesuai. Lalu desain yang efisien, memilih metode konstruksi dan fondasi yang paling sesuai dengan kondisi batuannya. Lalu selanjutnya keberlanjutan proyek, di mana memastikan proyek berlangsung tanpa adanya hambatan dan tanpa resiko potensial yang tidak terduga. Jadi teman-teman, Rock Quality Design atau RQD bukan hanya parameter teknis, tetapi juga pandangan mendalam ke dalam karakteristik batuan yang membentuk dasar proyek konstruksi dan rekayasa geoteknik. Menanamkan pemahaman mendalam tentang RQD bukan hanya menjadi kebutuhan, tetapi kunci untuk fondasi yang kokoh dan proyek-proyek yang berkelanjutan. Nah, untuk pemahaman yang lebih komprehensif, aku akan menampilkan video penjelasan mengenai RQD. Disimak ya.
Hello, so today we talk about what is RQD in geology. So in this video we also talk about the concept and relation of RQD with core recovery. So rock quality designation or RQD is a measure of quality of rock core taken from a borehole. It signifies the degree of jointing or fracture in a rock mass measured in percentage. Pieces of the rock whose length is less than 10 cm are not considered for calculation of RQD. RQD is defined as a sum of the core samples having a length greater than 10 cm divided by the total length considered or total core run. RQD value is calculated in percentage actually. So as you can see, this is the core recovered from a borehole. So first of all we just measure this the length of this core. Suppose the core is this one, what we have seen here. So the first length of the core is 38 centimeter, then 17 centimeter, then this portion is suppose fracture, so there is no core recovery, or the pieces of core is less than 10 centimeter, then 20 centimeter, and then 35 centimeter. This part is also less than 10 centimeter, so we are not considering this part is for calculation of RQD. Now see here, this is the formula to find out RQD. So RQD is equal to sum or total length of the core pieces greater than 10 centimeter actually, divided by total length of core run in 200. So the total length of core run is 200 centimeter, and the pieces what we have found is here 38, 17, 20 and 35. So total of this divided by 200 into 100 is equal to 55%. So this is the RQD. Let's take another example for understanding better. Suppose we have found this core from a borehole. So first of all we just find out the core recovery. So core recovery is equal to total length of rock recovered divided by total core run length in 200. So suppose we have recovered total length of rock is 25 centimeter, 20, 25, 19, 6, 8 and 12 centimeter. So this is the total of 115 centimeter, and the total core run length is 120 centimeter. So 115 is divided by 120 into 100 is equal to 96%. So this is the core recovery, actual core recovery. Now we should find the rock quality designation or RQD. So the formula of RQD is sum or total length of the sound pieces. Sound pieces means greater than 10 centimeter divided by total core run length into 100. So this is the core recovery, but what we have found greater than 10 centimeter is considered for RQD calculation. So 25, 20, 25, 19 and 12, 6 and 8 is not considered for RQD calculation because this is the less than 10 centimeter. So this is the total of 101 centimeter, and the total run length is 120. So 101 divided by 120 into 100, 84%. So this is the RQD percent for this core run length. So 84% is actually a good quality hard rock. Now see here the table that defined the RQD percentage. So if the RQD percentage is less than 25%, the rock is very poor or completely weathered rock. If the RQD is 25 to 50%, the RQD is poor. If the RQD is 51 to 75%, this is fair. 76 to 90 is good, and 91 to 100% is very good or fresh rock. Uses of RQD. So RQD of 75% or more shows good quality hard rock, and less than 50% shows low quality weathered rocks. RQD is used to evaluate RQD is used to evaluate the quality of rocks such as degree and depth of weathering, zones of rock weakness and fracturing. The information is used for determining the depth of foundations for tunneling, hydropower and other sectors, bearing capacity of rocks, settlement and sliding possibilities of foundation. In mining industry, it is used to determine fracture and jointing for better mining planning.
Good day, everybody. This video will be about rock quality designation index, or what we also briefly called RQD. So this is very important value. We use it for almost all classification systems. I'm going to show you how we can calculate this RQD, and for that we will just have a box with core samples, the one that you can see here. And you'll see there are different types of rocks. These black ones, very weathered, this is argillite, and we have this sandstone. So I'm going to calculate RQD for this particular set of rocks, which is 1 meter. So this is the total run of this rock, which is sandstone. And to calculate RQD, we need to measure the size of each of the core here. You see some of them are bigger than others, some of them are very small. So we will just need to estimate, actually measure the size of each of the rock. And if it's 10 centimeters or greater, we're going to use it for calculation of RQD. If it's less than 10 centimeters, then we will just ignore those samples. Pretty simple. So we'll start from the left, and I have a ruler here. So this first piece, it's about 75 millimeters, so which is less than 10 centimeters. We're going to ignore it. Next one is it's about 90 centimeters. 90 millimeters, which is 9 centimeters. Still, it's less than 10 centimeters. We'll ignore it. This sample, you see, it's broken. It's split, but the core is actually longer than 10 centimeters. You see that one. And we're going to include it in the calculations of RQD. That will give us 190 millimeters, which is 19 centimeters, right? So you see that next samples, this one is about 6.5 centimeters. This is even smaller, 5 centimeters. So we're not going to consider this one. So we'll consider this one, which is 190 millimeters. And then this small. This one, the last sample here, or like close to the last, this is pretty big one. And when I measure this one, it will give approximately 145 millimeters. So what we do next is we're going to sum the length of this core and this one, and we'll divide by 1 meter, because that's 1 meter of the total run of this rock. So which is 190 plus 145 millimeters divided by 1,000, which is 1 meter. And then we will change it to percentage, multiply by 100. It will give us approximately 33.5%, which is RQD. It's actually pretty low. What we would like to see, that there are more pieces which are longer than 10 centimeters. That will increase RQD. We'd like to see about 90–95%. That will be for really good quality rock. Thank you for watching this video, and have a nice day.